Hello and welcome to the 6th lecture of the ICS 103 programming. In this lecture we'll be basically discussing selection structures. Okay, so let's start. So an outline of what we're going to learn today is the control structures, and we're going to talk about conditions, relationship operators, logical operators, if statements. Okay, and in if statements we're going to be talking about two alternatives, one alternative, and nested if statement. And at the end we're going to be talking about the switch statement. Okay, so let's start. A control structure. When we talk about control structure, what do we mean? A control structure is the flow of execution in the program in a function. Okay, so usually in a compiler or in any program, the execution goes in C program, actually it goes line by line. So if you have a code that is written, it goes line by line into that code and it actually executes that function. So that is called a sequential flow. Okay, three basic control structure: a sequential flow. Then this sequential flow in C programming, you go line by line. The compiler is going to go execute the commands line by line and in sequence. And usually in sequential flow we write them in a block of code and we indicate to them by the open curly brackets. Okay, so this is what we indicate them by, the open curly brackets and the close curly bracket, and that indicates that everything between these two curly brackets goes sequentially unless otherwise you find another structure. Okay, this is something similar what you have been doing in the main function when you write int main void, and then you put two curly brackets. The program execution goes in sequence line by line in that. Okay, so that's a sequential flow. A selection control structure is a program construct that chooses amongst alternative statements to execute based on the condition. So what happens is your program comes sequentially, and then as soon as it hits, so it comes sequentially, and as soon as it hits the control structure that is selection, okay, the selection control structure, it basically decides whether to go on this side or go this side. So there are different statements that are written over here, and there are different statements that are written over here. Based on some condition that I'm going to be checking, the control structure is going to go either and conduct the statements that are on the right or conduct the statements on the left. On the contrary, the sequential structure is going to go in sequence. In each statement it's going to go one after the other, whereas in a selection structure there is some condition, and we're going to talk about the condition later on. There is some condition in which makes the compiler or the computer go either in one direction or go and execute another direction. Okay, so that's a selection statement or selection control structure. Okay, for example, compute the sum of two numbers and print the square root of the result if the sum is positive. Okay, so you check if the sum is positive. If the sum is positive, you do print the square root. If the sum is negative and the square root for the negative number is not defined, so you do not print the square root. So you have two statements that over here. One is to do the square root, the other is not to do the square root. And based on what do you do that? Based on a comparison of the sum. So you take a look at the sum. If the sum has a positive number, you take the square root, otherwise you don't take the square root. This is a typical example of a selection structure. In a repetition, a program is a program construct that is used to execute a block of code multiple times. Okay, so in repetition what happens, there's a condition and you check it, and if the condition is true, you keep on repeating the statements until the condition becomes a false and you get out. Okay, example of this is you want to read 1000 numbers, so you have you get a number from a user, then you get another number and you keep count of the numbers, and the number gets more than 1000, you actually get out of your structure. Okay, so the repetition structures we're going to be talking about in next lecture, so I'm not going to touch upon them in this lecture, but we're talking about selection control structures where you can actually have a branching in your program. Okay, so let's talk first about compound statements and what do we mean by compound statement. A compound statement, or sometimes called even a block of code, is a group of statements bracketed by the two curly brackets. Okay, so you have one open curly bracket and closed curly bracket. When you put these two, whatever is between them is called a compound statement or a block of code. Okay, and it's used to specify a sequential flow. So there is a sequential flow for you over here. You have the open curly bracket, closed curly bracket, and you have the statement. So your compiler is going to conduct statements one after the other in a sequential manner. So it's going to go line by line and conduct whatever statements that you put for it over here. Okay, An example of this is the main function and all the other functions that you might be working with. Okay, a condition. Now, to explain a condition, what is a condition? We say the condition is a way to choose among alternative statements. Okay, you need to write a condition expression. To choose from alternative statement, you need a condition. The value of a condition expression is either true or false. Okay, there are only two values that it can take, either true or false. So let's take an example of a condition A greater than B. Okay, now if A was equal to 1 and B is equal to 10, is A greater than B? Yes, A is greater than B, so the result of this will become a true. If, on the other hand, this is example 1, and I'll take you example 2, if A was 10 and B was 5, okay, is A greater than B? No, A is not greater than B, and in this case we say that this condition results with a false. Okay, so this is true and this is false for this condition. Okay, so depending on the value of the variables, this condition is going to return either a true or false. Okay, now in C, if the condition is a false, the compiler returns a 0. Okay, very important to note that the compiler returns a 0 if the condition is false. If the condition is true, it returns anything except 0. Okay, so if you look at it as a line that goes from minus infinity to plus infinity, you have 0 over here. So you take out 0, and that is your set where you have defined false. So false is equal to the set 0. Okay, this is mathematical representation, and this is a hollow this is a dotted dot because false is 0. Now true is equals to false complement. Okay, or it's actually equals to, you take all the numbers, so this minus infinity to infinity minus 0. Okay, so this is what is represented by true. Okay, now the compiler denotes to all of these numbers by 1. So whenever we say that its a value is true, we will refer to 1 as the value is true. However, any value that you can have in this period, so any value that's going from minus infinity to infinity, not including 0, could represent a true value. Okay, the compiler, we will denote to it by 1, and the compiler usually uses 1 as a result of a true. Okay, however, any other value that is not 0 is represented as true. Okay, so any non-zero value, that is the key word that we want to learn over here. Okay, but when we are using it, we will say true, we will denote to it by 1. We will use 1 to denote to any value that is between minus infinity and infinity. Okay, how to write a simple condition. Okay, so let's talk about conditions and how we can actually write conditions. Most conditions that we use to perform comparison will have one of the following forms. Okay, so there's only few forms that you can have. You can have A less than B. Okay, relationship operation. So A less than B, A greater than B. There is an equality operator, and the equality operator is A equal to, and note the double equal to sign. So we are writing here A equal to B, and this is telling the compiler, hey, please check if A, the value of A, is equivalent to the value of B, and this is returning either true or false. Okay, this is different than A is equal to B, where A equals to B is an assignment operator. So you take the value of B and put it in A. That is why in comparison we put double equal to sign, and please do not forget the double equal to sign. Okay, there is a not equal to operator, and we denote a not equal to operator by the exclamation mark and equal to. This is not equal to. Okay, so these are the type of operators. So equality operators and relation operators. Relation operators such as less than, greater than, less than or equal to, greater than or equal to, or anything else that you might be basically using in your programming. Okay, so let's look at the operators, and here are the list of all the operators. Less than operator, it's a relation operator. Greater than operation, also a relation operator. Less than or equal to, greater than, equal to, and this is exactly how it's written. Do not write it equal to, less than. That compiler will not accept it. Greater than or equal to, this is another relationship compiler. Equal to is the equality compiler. This is in math, this is equal to A equal to B. So you can say if A equals to B, this in C is written if A equal B. Okay, so this is how you write it in C. This is how you write it in math. Okay, so this is a check if A is equal to B, and this is a check if A is equal to B in math. This is in C. In C, this means assignment operator. So make the value of A equal to the value of B. So take the value of B and put it inside A. Not equal to is another equality operator. Okay. Sorry. Now we come to logical operators. To write more complex condition, we can combine simple condition with logical operators. Okay, what are logical operators? The first operator that we're going to be introducing is the AND operator, and this is how we write it, with double AND sign. Okay, and it means an AND. An example is we have A and B is true if both A and B are true. Okay, so this is the AND operator. We also have an operator called the OR, and this is how we write it. And this is the OR operator. We could say A or B, and this is true if either A is true or B is true. And then we have the NOT operator, and the NOT operator is the negation, where if you had a true value and you negate it, it'll become false, and if you have false and you negate it, it'll become true. Okay, this means the logical complement. So the logical complement is also known as the NOT operator. Example is if you have a condition and you NOT it and you actually complement it over here. If it's true, it becomes false. If it's false, it becomes true. So how do we use this operator? Here's an example. Suppose I'm working for the housing department of a university, and I have some rules that I have to follow. So I say if my salary is less than 10,000, or the number of dependents is greater than 5, then I have to give you a large house. Okay, so if you have your salary is less than 10,000, so that means that you are not that highly paid, or you have a dependent that are greater than 5. Okay, so you have, let's say, 5 children. That means that you have to have a big house. So whenever this condition becomes true, you get a large house, or this condition becomes true, so you get a large house. Okay, another example is if the temperature is greater than 40 and the humidity is greater than 90. In most equipment manufacturer will put for you, if the temperature goes above 40 and the humidity is higher than 90, then you have to stop operation and shut off the machine. So you actually check if the temperature is greater than 40 and the humidity is greater than 90, then you stop. If one of them is not greater than the value that was set, so if the temperature was not greater than 40 but the humidity was greater than 90, you don't stop operation because the temperature is quite low. And the same is true for the other way. Okay, and the NOT operator over here, the NOT temperature greater than 90 means is the temperature greater than 90. This is the condition that you check. If this is true, then you negate it and it becomes a false. Otherwise, if this was false, you negate it, it'll become true. Okay, so this is basically how the operators are operating. Okay, so different type of operators. So now let's look at the truth table of an operator. Okay, a truth table is the exhaustive list of what the operators can do with 2 different values or whatever values that it takes. So suppose we have 2, A and a B. These are 2 conditions, and the value of A is false and the value of B is false, and you AND the 2 values A and B. So you AND the values, so false and false result in a false. Okay, false and true result in a false, true and a false result in a false, true and true result in a true. So if you had a condition that was true and another condition and you have a true, and then you AND them together, so the results becomes true. Okay, if you have a condition that is true and a condition that is false, you AND them together, you get a result that is false. Okay, now you have to memorize this table, and the easiest way to memorize this table is you say that when you are doing the AND operation, when you do a true and a true, you get a true, otherwise you always get a false. Okay, so you only have to memorize one for the AND. The true and true gives you a true. If one of them becomes a false, then the condition becomes false when you use the AND operator. Okay, so this is called the truth table of the AND operator. And you'll be using this quite extensively in your labs and in your life actually. And the AND operator is one of the most common operators that's being used. Okay. Okay, the second most common operator is the OR operator, and the OR operator is that you have a condition A and you have a condition B in the same fashion if you want to do A or B. So you say if you had the condition A to be false, condition B to be false, you A or B, you get a false. If you had a false and a true, you get a true. If you had a true and a false, you get a true. If you have a true and a false, the OR results are true. Okay? So the way to remember this is in the OR operator, you only get a false if both conditions are false. If both conditions are false, you get a false. Otherwise, you always get a true. Okay? At least one of them is true, you always get a true. So this is the truth table of the OR operator. Now, we'll go to the NOT operator, and this is the negation operator or the complement operator, and this is the easiest type of operator that you know. Is when the condition A is false and you negate it, you get true. When you get true, you negate it, you get false, or you complement it, or you use the NOT operator, you get the opposite of what the condition you are doing. Okay, so these are the operators that we are basically using. Okay, so here's an example, and the example is giving you a period in which you have a minimum and maximum, so your numbers are over here. When you complement this and you knot it out, you get a period that is greater than your minimum and larger than your maximum. Okay, so if you want a number that is over here, for example, what type of operation are you going to be using? You're going to say my number, which is x, the x has to be greater than the minimum. Okay, the second condition that you have is x is less than the maximum. Now the question comes, what are you going to use as an operator in the middle? Are you going to use an AND or are you going to use an OR? Okay, so this number to lie in this line, in this shaded area, sorry, the x number has to fulfill both minimum and maximum conditions. So it has to be greater than the minimum and less than the maximum. So to fulfill this, you will use the AND operator to tell the user or tell the computer that it has to be greater than this and smaller than this to be a number that is between min and max. Whereas if you had the number x over here and you wanted to calculate this, so you're going to put x is either greater than y or x is greater than z. And over here, what is the operator that you're going to use? You're going to use the OR operator. Why are you going to use the OR operator? Because you could be either here or here. It doesn't matter. You are in the period that I'm over here. So you use the AND operator if you were bounded by two limits. And if you are bounded by one limit, you will use the OR operator. Okay, so this is an example that's explaining how the AND and OR actually work. Now, can we actually combine all operators in the expression? And the answer is yes, you can combine an operator, all the operators in an expression in order to have a complex expression. But the problem then becomes that the expression is then evaluated and there is an order of precedence. The compiler will give precedence to some operator than others. So for example, if you had A or, and between brackets, y greater than or equal to x minus z, how is the compiler going to go and actually evaluate this? So the first thing the compiler is going to look at is going to look at the parentheses and is going to solve anything that is between the parentheses. So this is the first thing that it's going to look at and it's going to solve it. Now inside over here, it's going to look for, first of all, it's going to look for all the unary operations, the plus and minus, and the negation logical operator, because also the negation operator is a unary operator because it takes only one variable. And the typecast. So when you go inside here, you're going to see that, okay, I don't have anything from these. So you go to the next level, you multiplication, division, and modulus. And you do this from left to right. I forgot to do the left to right. Let me go back over here. Parentheses. If you had more than one parentheses in the operator, in the expression that you have, you solve the parentheses from left to right or from inner to outer. Okay? If you have a unary sign or a negation sign, a logical negation, or a typecast, you go from right to left. And if you have a multiplication, division, and modulus, you go to the multiplication, division, modulus from left to right. So in this case, you don't have any multiplication, division, modulus. So there's no that. There is no operation over here. Then you go to the next operation, which is the addition and subtraction. This is the binary addition and binary subtraction. And you go from left to right. And over here, you do x minus z. This is the first thing you do. Then you have the less than, equal to, greater than equal to. These are all relation operators. You go from left to right. So this one will be done first. Okay, so there's no other operation. So this is the operation that's going to do that. Then you go to the equal to sign, not equal to sign, and this is a relation operator that goes from left to right. Then you use the and, this is the logical and. Then you use the logical or from left to right, and the equal to is from right to left. Okay, so notice over here, this is right to left, this is right to left, and the rest of it is left to right. Okay. Okay, so these are the order of operation, and this is the order it will go through. So it will give high priority for this one. So it's going to do this first, and low priority for this one, and this is going to do this last. Okay, and this is how the compiler is going to go. So let's go to the example and draw a tree of how the expression is going to be evaluated. Okay, so in our case over here, this is a more complex example. We're saying not flag or y plus z greater or equal to x minus z. Okay, so we copied the same thing over here. So I have the same equation that is written over here. I just wrote it over here, and I'm assuming over here that flag is 0, y is 4.0, z is 2.0, and x is 3.0. Okay, so these are all values of the different variables that I have. Now taking the order of precedence, the first thing we have to evaluate in this expression would be, and I forgot, actually this is a mistake, and there's the closed bracket over here. We have to first go to the parentheses and solve what is inside the parentheses first. Okay, and inside the parentheses we're going to be using the order of precedence, and based on the order of precedence, first we will go and look at any unary. Do we have any unary signs over here? No, we don't have any unary signs over here. No typecast and no negation. So we go to the next one, multiplication, division, and modulus, and we go from left to right. So do we have multiplication, division, and modulus? No, we don't. And then we go to the next operation, which is the plus and minus. So we do first add 4 and y and z. So y has the value of 4 and z has the value of 2. So we get the 0.6, and this is the first operation that we're going to do. Okay. Then the second operation we're going to do is the subtraction. So 3 minus 2, we're going to get 1. From 3 minus 2, we get a 1, and 4 plus 2, we got a 6. Then the third operation is we go to the greater than or equal to sign, and we check if 6.0 is greater than 1.0. Is 6.0 greater than 1.0? Yes, that's true. So I'm going to return a true value, and the true value I told you is denoted by 1, so it's going to return a 1. Okay? Now this is 1, and at this stage we finish the parentheses. Then we go by the order of precedence and do the not flag. The not flag, the flag was 0, the not flag will become 1. So not flag is 1, and then we have the or sign, 1 or 1 will become 1. So the result of this expression is 1. Okay? To do the tree, here's what's going on. This is the first operation that you're doing. So I'm just going to write it first operation. Then this is the second operation that you're doing. Then you're doing the third operation, which is the comparison. And then the fourth operation is the negation. And the fifth operation that you're doing is the or sign. And that will result to you as a 1. Okay? So here's the example of how we actually can do the order of precedence in a complex expression. Okay? Now, make sure your condition is logically equivalent to the English statement. Okay? If you want to say x and y are greater than z, do not write x and y greater than z. Okay? This is wrong. Why? Because in the order of precedence, what's going to happen? When we say x and y are greater than z, in English we mean that x is greater than z and y is greater than z. Over here in the order of precedence, I'm going to do this first, and x and y. So I'll take the value of x and take the value of y, and I add them together. If this is true and this is true, it's going to become true. Is it greater than z? So this is going to result to me, this is going to result to me either with a true or false, 1 or 0. Correct? So I'm going to check it with the value of z, and then I'm going to be either checking is 1 greater than z or 0 is greater than z. And this is not what we want to do. Okay? What we actually want to say is x greater than a and y is greater than z. So we evaluate if x is greater than a, we get a 0 or 1, and we get to evaluate y is greater than z, we get 0 and 1, and then we add the condition to get if both of x and y are greater than z. Okay, so this is the right way of writing it. This is the wrong way of writing it. So make sure that you do follow the order of precedence and you write your expression equivalent to what do we say in English or what do you see in the math books. Okay, complementing a condition. To complement a logical expression precedes it with a symbol not. Okay, so this is how you do a complement, or you actually negate the statement. Okay, so let's take the example. Age equal to 50. So over here I'm checking if age is actually 50. If the value that stores in age is 50, then this condition will return true, otherwise it's going to return a false. When I say not age equal to 50, this is equivalent of saying age is not equal to 50. Correct? So because over here I'm checking if the age is equal to 50. If it is true, I'm going to negate it and this becomes false, and if it's false, I'm going to negate it becomes true. So it's equivalent of saying age is not equal to 50. Okay, and the same goes for the relationship operator. Can change as follow. So if you had a less than or equal to and you negate it, it's going to become a greater than. Okay, and the example of this I'm going to show you on a real line. So suppose I'm using less than or equal to. So I have my I'm going from minus infinity, for example, to a number x, and I say I want the period where x is less than or equal to, let's put this a number 5. Okay, so that means my x lies over here, correct? Including, so this is my arrow, so including, this is going to infinity. So if this x is less than or equal to 5, that means from 5 and below, this is the period that I am in. When I negate it, I have to take the period, disinclude the 5, and take the period over here, correct? So this is the negation. So I do not put the equal to sign. So when I negate a less than or equal to, I get a greater than sign. Okay, so when I negate this, x should be greater than 5. This is the result of this negation. Okay, because the less than or equal to, I include the 5, and when I take the opposite of it, it's actually saying that this is the real line. So r, okay, minus, we take the period from minus infinity to 5, and this is equivalent of saying this is 5 to infinity, but 5 is not included. Okay, oh sorry, this is a circle. In the same way, if you have a period which is let's say you have from minus infinity to 5, which is not included, and you negate this, so this becomes r minus, you negate it, so you actually are saying this is equal to 5, which is included, to infinity. Okay, so again, in the real line, if you had a period which is coming from minus infinity and to 5, and the 5 is not included, when you negate it, you'll have to include, so the negation will be include the 5 and go to infinity. Okay, so less than or equal to becomes greater than, less than becomes greater than or equal to, and so on. In the same fashion, you can actually understand the rest of the conditions. Okay, now we're talking about character comparison. C allows character comparison using relation and equivalent operator. Okay, why does it allow that? It's basically because C treats the character as numbers and they are presented by the ASCII code. Okay, so when you are doing during comparison, okay, you can actually put alphabet and compare them. What the compiler will compare is the ASCII code behind these numbers. So the letter 9 or the character 9 is stored into the memory as a number. Okay, and you get the number using the ASCII table. And when you get the number from the ASCII table, compiler is going to compare that number to the number that's stored in the ASCII table for 0. Okay, now in the ASCII table, there's a structure that they put 0, 1, 2, going up to 9, and they give this as a value of x. And this one x plus 1, and this one x plus 2, going on to x plus 10. Okay, so basically what they're doing is they're going and giving each one, this is the ASCII value for it. And similarly for small a, small b, small c, up to small z, they have given values w plus 1, going on to w plus 26. Okay, so this is actually 9, not 10. And then capital A to capital B to capital Z, they have given it with the y plus 1 until y plus 26. Okay, so this is how the ASCII table is actually structured. So you do not actually have to know what is the value of an ASCII character to actually compare it. If you know what are the values, so you know 0 and 9, they are consecutive values, each one is 1 greater than the other, and then I come and tell you if 9 is greater or equal to 0, is 9 greater or equal to 0? Yes, 9 is actually greater than or equal to 0, so this results with a true. If I said 9 is less than or equal to 0, is 9 less than 0? No, the value of 9 is less than the value of 0, so that means that this result will false. If you say A is less than E, this becomes a true. So you could look at the values of small a to small e. The values are incrementing. So a is the smallest value, and then we're incrementing, going to the small z. So if I compare small e with small a, the value of e is greater than the value of a because it comes lower, and this condition becomes true. Sorry. You can also put an AND condition. You can check a character. If you have a character, you can check if it's greater or less than, so is the character greater or equal to A, and the character is less than or equal to Z. So you're basically checking if it's greater or equal to A and less than or equal to Z. So you're checking if it is in this period. If it is in this period, you can safely say that this character is a small letter character, okay? So this is how the ASCII characters are structured in the ASCII code, and this is what we expect you to remember, and this is what we want you to come out with, that the ASCII code is actually structured in a manner that can help you determine if these conditions are true or false, okay? So each ASCII code is represented by a number. So for 0 I put 1, for x the representation of it, I do not know what x is, it's a number, but I know that 1 is the character 1 is 1 addition to the x, character 2 is 2 addition to the x, character 3 is the 3 addition to the x, and character 9 is 9 addition to the x, okay? And the same way goes for the ABCs from the character. So let me just put them in as we write them in C so that you can distinguish between the characters and what is written over here. Okay, so this is basically what happens in the ASCII characters, and this is why you can actually compare the ASCII characters, okay? Now we're going to teach you the DeMorgan Law, or the DeMorgan Theorem. It's a way of simplifying logical expressions, okay? The theorem states that the complement of a conjunction is the disjunction of the complements, or vice versa, okay? Very large English words. I'm going to simplify them for you. What does it mean? If you had an expression x or y and you want to negate it, you use the DeMorgan Law to do that, okay? And what does the DeMorgan Law states? It says when you have a bracket and you have a negation outside it, when you open the bracket, you have to distribute this on all of the operators, okay? And this one was going to go, it will become not x, and then you will have to do a not or. A not or is equivalent to an and, okay? So the or will change to an and then you negate the y, the not y. So not x or y becomes not x or and not y. In the same fashion, not x and y, you'll have to distribute the not onto the x, the not onto the y, and the not onto the or and, which will return it to an or. So you shift the and to an or and the or to an and, okay, when you negate the operator. Okay, so this is the DeMorgan Law. Now, why do we use the DeMorgan Law? Because sometimes it makes our computers much more faster. Okay, for example, over here, how many operations do I have to do to complete this expression? To complete this expression, I have to do 3 operations. I have to negate the x, negate the y, so I take the not x, this is the first operation, then the not y, so I'm going to put this as the first operation, this as the second operation, the not y, and the result of this I have to OR, so these are 3 operations that I have to do. Okay, so these are 3 operations that I have to do to complete the statement. Now this is actually equivalent to this statement where I have to take, this is my first operation, where I do an x and y, and then I have to negate it, so I have 2 operations. Okay, so I get the same result as this by doing 2 operations. This makes your life faster in a computer. Instead of doing 3 operations, you're doing 2 operations. Okay, so this is why it is more time efficient to write this than this. Okay, so a good optimized code will have this, and a bad optimized code will have this. Okay. The example that I'm getting over here is if it is not the case that I am tall and thin, then I am either short or fat. Okay, or both. So this is how you're actually doing it. So if you just look at it, it is not the case that I am tall and thin, so I'm neither tall nor I'm thin, then I'm either short or fat. Correct? So I'm telling you I'm not tall and thin. That means I am either short or I am fat. Okay? The theorem can be extended to a combination of more than 2 terms in a similar way. So you can actually say x and y and z. For example, if you negate it, this is equivalent to saying not x or not y or not z. Okay? So this is equivalent to this, and you can actually extend it to any number of variables that you like. Okay, so this is the DeMorgan theorem. Now the DeMorgan theorems are extremely useful in simplifying expressions from AND and OR. For example, if you had the if not A and not B, you have 1 operation over here, 1 operation over here, this is 1, this is 2, and then you have this as 3 operation. If you use the DeMorgan law and you take the not out, then you will have A or B. This is the first operation, and then the result of this will be noted. This is the second operation, so you can have 3 operations here and 2 operations. Okay, now you might think of that, well, what the heck, what are 3 and 2 operations make a difference? Well, if you don't take this in consideration in very large programs, and suppose you have 5 million of these operators that you did not do, so you are actually doing 3 times 1 times 5, that's 5 million more operation when you do this type of programming than this, and 5 million operation then take a long time, and this is how the time accumulates. And when you're writing an optimized code, you should be going to something like this. Okay, now compilers, usually some compilers do the optimization for you automatically. Okay, but that's not true for all compilers, so that is why we're teaching you, so you will be in control. Okay, now we'll talk about an if statement. Okay, what is an if statement? The if statement. The if statement is a control selection statement, and what happens is when your program comes running, it's going to hit a condition. Okay, and when it hits a condition, it's going to determine if this condition is true or false. If that condition is true, indicated by T over here, it's going to go and do a certain task, and if it's false, it's going to go and do a different set of tasks, then continue your program in both cases. Okay, so for example, if this was a health program and you were actually testing the rest heart rate, so you take the heart rate of a person, so you take the heartbeat and when he's resting and you check it. If this is greater than 56, okay, if that condition became true, display your heart is in excellent condition. Okay, your heart is good, you're beating the rate that a normal human being should be beating. Okay, but if the rate is less than this and this condition becomes a false, you display keep up your exercise program. Okay, so you tell him, please do some more exercise because your heartbeat is low, so your heart has a problem. Okay, so here's how the program will go. It'll come, check the condition. If this condition is going to true, it's going to display this for the user and continue your program. And if this condition is false, it's going to display this and continue your program. So it's either this or this that you select, okay, depending on the condition. And this is an if statement. And this is how you basically write an if statement. You write if, and between brackets you put a condition, and then in between curly brackets you put the compound statements that you want, else in between curly brackets you put the compound statements. So your program is going to come run, check this condition. If this condition is going to true, it's going to conduct these statements between these two curly brackets and then jump out the else and continue your program. If this condition is not true, it's going to jump to the else, conduct these, and then jump back and continue to the program. Okay, now an example over here is if I were working in a car manufacturing machine and my job is to determine if the car is safe or not. I'm going to take 100 cars and I'm going to crash them, and I'm going to put dummies in them, and in the dummies I'm going to put some type of sensors that are going to check for me how much pressure is exerted on the dummy, so that I can determine if these forces are less than a number that is published to me, which is the maximum safety critical by the health organization. If it's less than that, that means that the forces are lower than what the maximum the user can, a human being can handle. That means that my cars are safe. If the forces were very high, higher than the maximum safety critical, that means that the forces are too high and the person is going to die. So my car is not safe. Okay, so this is the program that I want to write. So I write if crash test rating index, these are the forces that I get from the sensors that I have on the dummy. If those ratings are less or equal to the maximum safety critical, so this is the maximum force that the human being can handle, I say my car is safe. Okay, and then I can add the number of cars, the safe cars, by 1. Okay, so I have 1 safe car. Then I go crash the second car and I check is the crash testing rating index is less than or equal to the safe. Suppose that this is true, so I'm gonna print the car is safe and add 1 to the safe car, so now I have 2 cars. Then I'm going to crash the third car and check this, and suppose this condition was false. So the third crash that I did, the crash test rating index was more than the maximum safety critical, so I'm going to go over here and I'm going to print the car is unsafe, and now I'm going to add 1 to the unsafe cars. Okay, so I have 1 unsafe car, 2 safe cars, and I'm going to be repeating this again and again and again and again. I'm going to crash cars, and I'm actually going to test these things, and at the end I'm going to have how many safe cars that I have and how many unsafe cars that I have, and based on that I'm going to determine if my car is safe or not. Okay, so if the number of safe cars are more than the number of unsafe cars, I'm going to determine that this car is safe. If not, then I'm going to determine that the cars are unsafe. Okay, so this is how we basically are determining and using the if statement. Okay, so now, one basic rule in the if statement is that after the if statement, do not put a semicolon over here. Okay, so there is no semicolon. After the if statement, you start the curly bracket and close the curly bracket, and between the curly brackets, you can write all the statements that you want to conduct when this condition is true. And in the curly brackets of the else statement, you write all the statements that you want to conduct if this condition was not true. Now, having said that, if you had only 1 statement inside your if statement, you can delete the curly brackets. Okay, however, it's a good practice to even put the curly brackets even if you have 1 statement left, okay, in the if statement or the else statement. Okay, and we'll have examples in the following slide where I'll show you. Okay, so I explained this. So the bottom line over here, you must use braces or curly bracket if you want to execute a compound statement in the if statement. Okay, so if you have more than 1 line in an if or in an else, you'll have to put a curly bracket. Now, you do not need the curly brackets if you have only a single line inside the if and an else. Okay, so for example, in the example that we were showing you before, if you're measuring the heart rate and you're working in the health industry, you say if the rest heart rate is greater than 65, that means your heartbeat is normal. You print up, if your heartbeat is greater than 65, keep up your exercise program. If your heart rate is not greater than 65 and you're resting, that means that your heart is good. You say your heart is in excellent health. Okay, so this is the 2 examples that we have for you over here. Since there's only 1 statement here, I do not need the curly brackets. Okay, But it is good to put a curly bracket. If I were you, I would put the curly brackets over here to indicate that there is only one statement, so I'm safe. However, in the exam, and when we're testing you, we might give you a code such as this. So since there's only one statement inside the else, I'm not going to put the curly bracket, okay? If I put any other example over here, x is equal to 5, for example, this is outside the if structure, it's outside the if statement, so you do the else and then you continue your program from here. Okay, so the curly brackets are not something necessary to put if you have only one statement in the if and in the else. If you have more than one statement, then you have to put them, otherwise you may find that you run into errors. Okay, now let's talk about one alternative. Okay, and in the one alternative, your program is going to run normally and check a condition. If that condition is true, it's going to conduct some statements. If it's not true, it's just going to jump and continue your program. This is a one-way alternative. Okay, so suppose you're going to be doing a product, okay, or a division, and you first of all, what you do is say if x is not equal to 0. So you're doing a multiplication and you check if x is not equal to 0. If x is equal to 0, that means that you don't want to do the multiplication. So if x was 0, you're going to jump and continue your program normally. If your x is not equal to 0, then you're going to come in and you're actually going to conduct the statement where you're going to be saying the product is equal to product multiplied by x. So you multiply x by the product and save it into the product, and you continue your program. Okay, so this is the flow chart of it, and this is how you can see actually how the program is running. It's going to check if x is not equal to 0. If this is true, you're going to say product is equal to product multiplied by x. If this is false, you're just going to jump this line and you're going to continue your program. Okay, so this is a one-way alternative, and we showed you the two-way alternative in the example before it. Now we talk about a good programming style. You can assign an integer type variable a non-zero value for true or 0 for false. Very important. You can put non-zero value for true or 0 for false. Okay, so very important. Non-zero for true, 0 for false, and you can put this in any integer variable, and then you can put it in a logical operator and it's going to operate fine. Okay, so example over here is I have a variable called even is equal to, and I put in it the number that I have, n modulus 2, and I equal it to 0. So if the user inputs a number for me, n, I'm taking the modulus 2, so I'm taking the remainder of 2. The remainder of 2 can either be 0 or 1. This is basically checking for me if the number is even or not. Okay, how is it checking for me? Suppose I have a number that is 4. 4 modulus 2 will become 0. Is 0 equal 0? Yes, that's true. So a true value is going to be stored, and even a true value is represented by a non-zero number. We will take 1 to denote to it. Okay, so this is the even value. Then we can check if even, I do something. Okay, so I can check if even. So even will have either a 0 or a 1, and if it's an even number, I do something. If we take the value of 3, which is an odd value, 3 modulus 2 will become 1. Is 1 equal to 0? That is false, so I'm going to return a 0 into the even, and if even, this will become a false, and you can actually jump out the if statement and continue your program. Okay, now a better way of writing this is you hash define false to 0, hash define true to be not false. Okay, so it's any number that is not 0. And in the function or in the program, you can come and say even is equal to n modulus 2 equal to 0, and here basically you're checking if your number is even or odd. If it's even, it's going to return a true, and if it's an odd, it's going to return a false. And then you say if even is equal to true, the true is any non-zero value, then you do something, and this is equivalent to this code. Okay, so this is how we actually check even and odd numbers. Now I'm going to talk about nested if statements. Okay, so far we have used if statements to code decisions with one or two alternatives. A compound statement may contain more if statements. In this section we will use nested if statement, and here is an example. Suppose that I want to determine if a number is positive or a number is negative or a number is 0, because 0 is neither positive or negative. I can write over here if x is greater than 0. If I write x is greater than 0, then the number of positive numbers, I want to add them by 1. Okay, so I want to have one positive number. Else, if x is less than 0, I put the number of negative numbers equal to the number of negative number plus 1, else I put the number of zeros equal to number of zeros plus 1. What did I do over here? I have over here, so prior to this, I did not show you this over here in this code, but the num pos is equal to 0. I put num neg, which is number of negative numbers, equals to 0, and num 0 is equal to 0. So this code I put in prior to this, and then I ask the user, so I can use scanf, and I can say percentage D, and the address of X. I have int X over here also, and the address of X. So I take a number from a user, and after I take a number a user, I come over here and determine if this number is positive, negative, or 0. And I add it into the number of positive numbers, the number of negative numbers, and number of zeros. I say if X is greater than 0, so the user is going to enter a number. So I'm going to take that number, then I'm going to check if X greater than 0. Is it greater than 0? If it's true, I'm going to go to the number of positive numbers equal to number of positive number plus 1. So I'm going to add 1 to it, and then I'm going to jump out of my if statement. I'm not going to check any other condition, because the first condition that is true, I'm going to jump out of my if statement. So the if statement starts from an if, then it has an else if, and else, so I jump to the end of my statement. If the user did not enter a positive number, I'm going to go and check else if, so this condition becomes a false. So suppose the user enters a negative number, this condition becomes a false. I jump to the next else if. In the next else if, I look at the X. Is X is less than 0? If this condition is true, I'm going to go over here and I'm going to conduct the statement. So I'm going to put the negative number is called negative number plus 1, and then I'm going to jump out of the if structure. So I'm going to go out of the if statement and the else. Okay, so I'm going to jump over here if this condition is true. If this condition was false and this condition was false, so suppose the user entered 0, this is false, I'm going to go jump to the else and I'm going to conduct the statement. So I'm going to check the statement. Here's how it goes. I'm going to check the statement if it's true or not. If it's true, I'm going to conduct this and then jump out. If this is not true, I'm going to go check this statement. Is this true or not? If this is true, I'm going to conduct this and jump out. If this is not true, I'm going to go to else and conduct this statement. Okay, so you can have else, if, else, if, else, and you will actually cover the entire spectrum of the possibilities that you have in this condition. Okay, so if the number was positive, you're going to add 1 to the number of positive numbers. If it was negative, you're going to add 1 to the number of negative numbers. If it was 0, you're going to add 1 to the number of zeros. Okay, so this is basically how the if, else, if, and else works. Okay, now as a beginner programmer, most people like to write the program if X is greater than 0, number of positive numbers is plus 1. If X is less than 0, number of negative numbers equals number of negative numbers plus 1. And if X is equal to 0, number of zeros equal to number of zeros plus 1. Okay, this code is going to generate the same thing as the previous code. Okay, so if I just put this side by side here, this and this are equivalent. Okay, however, this code is much faster than this code. Why? Suppose that the user enters a positive number. Okay, over here in this program, I'm going to check if this number is positive. If this number is positive, I'm going to add the positive number by 1, and I'm going to jump out of my if statement and continue. Over here, I check if my number is greater than 0. Yes, it's true. I'm going to go and add to the number of positive number by 1. Then I check if the number is not 0, because I finished the if statement. There's a new if statement over here, so this is a new structure. So I check if the number is negative. Now the number is positive, so it's not negative, so this is not true. And if this X is equal to 0, so the number X was positive, so it's not equal to 0, so I'm going to jump over here. So I wasted the time of the compiler actually checking these two statements, whereas I can make a much efficient code if I have written this. Okay, so this is not an efficient code. This is a much more efficient code. The other thing that you have to remember, that when you jump from the if to the else if, you come with a history. Okay, so suppose in this code that you have if X is greater than 0 and the user entered a 0, for example. So the user entered over here a 0. Is X greater than 0? No, X is equal to 0, so this is not true. So you jump over here. Is X less than 0? Okay, now this condition is also not true, but when you come to this condition, you already know that X is not greater than 0. Okay, over here you check this. that this is not less than 0, so you come to the else, and when you come to the else, you know that the x is not greater than 0 and not less than 0. That is why you put the else case and you add the number of zeros over here. Okay, so there is a history that comes over here which passes down into the if statement. Okay, over here there is no history. Okay, so this is the if statement, and over there you finish it up and there is a new if, so it starts a new structure, so there is no history, and that is why your code is less optimized in this example. So don't use this, use the other example that I showed you earlier. Okay, now you can have multiple alternatives, and this is something very permissible in C. You can have if and between brackets condition, then you conduct statement 1, else if another condition is statement number 2. You can have else if condition number 3 is statement number 3, and go on, else if condition n statement number n, and else you put a statement. What happens over here, if condition 1 is true, is going to conduct the statement in condition 1 and jump out of the if statement. It will go out the else. If this condition is not true, it's going to check the second condition. If this condition is true, it's going to conduct the second statement and jump out of the if structure, so after the else. And if the nth condition was true, it's going to conduct the nth condition and it's going to go out of the else. If none of these conditions are true, it's going to go to the else and conduct the statement of the else. Okay, now you can have an if with an else, you can have an if with an else if else, you can have an if with else if else if else if else if else, and you can have an if with else if else if else if without an else. Okay, it's up to you to determine what do you want in your program and what is the requirement of your program and how your logic is structured to use what type of if statement you'll be using in your program. Okay, so here is an example, and in this example we are given a person's salary and we want to calculate the tax due by adding the base tax to the proper of the percentage times the excess salary over the time minimum salary for that range. Okay, so here's basically how you're going to be calculating the tax. So these are the salaries that you have. So you have from 0 to 14,999.99 to less than 15,000, from 15,000 to less than 30,000, from 30,000 to less than 15,000, from 50,000 to less than 80,000, from 80,000 to more than 150,000. Okay, so if your salary was between 0 and 15,000, you basically are asking the base tax of 0 and you pay 15% of the amount that you earn. Okay, so this is the tax that you're going to be paying. So the tax is calculated 15% of your earning plus the base tax. If you were paid 15,000 to 29,000, you will pay $2,250, okay, or reals or whatever. You're going to pay 2,250 whatsoever. This is the base tax because you are between 15,000 and 30,000. So you will pay this, you'll pay this. This is a fixed amount that you're going to pay. In addition to that, you're going to pay 18,000 of your current salary minus 15,000. Okay? And if you were between 30,000 and 49,000, you're going to pay 5,400, and you're going to pay, in addition to that, 22% of your salary minus 30,000. And if you are in this bracket, you are between 50,000 and 79,999, you're going to be paying 11,027 of your salary minus the 50,000. And if you are in this bracket, you're going to be paying 21,600 plus 33% of your salary minus the 80,000. Okay, so this is how you calculate the taxes. If you are paid more than 150,000, that means that you have to contact the department who's calculating the taxes, and you will be basically told what taxes that you have to pay. Okay, if you're paid less than 0 or 0 actually, then you don't have to actually pay taxes. Okay, so if you want to write a program that does this, how would we write our if statement? Okay, so over here, this is how we write it. If we say if your salary is less than 0.0, your tax is minus 1. Okay, that means I cannot calculate the tax for you. Why can I calculate the tax for you? Because you're not paid. Okay, so you don't need to pay, or this program will not calculate the tax for you. Okay, else if your salary is less than 15,000. Okay, if your salary is less than 15,000, that means that the tax is 15% of your salary. Okay, this is what the example was telling us to do. Okay, so if your taxes is 0, you pay 15,000 of your salary that you have earned. Okay, so you pay 15% of the salary. Else if the salary is less than 30,000, so you're in the second bracket, so your tax has 2,250. This is an amount that you have to pay. So we put this over here, and then we add to it 18% of your salary minus the 15,000. That's the base of that bracket. So you'd subtract this, take 18%, add it to 2,500. That is the tax that you have to pay. Okay? Sorry. I just don't wanna. Yeah. Now, over here, if your salary was less than 15,000, so you're in the next bracket, you basically are paying a tax of 5,400, which is the base, and 22% of your salary minus 30,000, which is the base of this, the second one, okay? And going on. So you put this according, so this one is for this else if is for this condition, 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 okay? And you calculate the taxes, the percentages minus your salary minus this plus this, percentage of your salary minus this plus this, and going on, we have all put them together, okay? So if your salary was more than 150,000, your tax is minus 1. This is what I'm telling you, that I cannot calculate your taxes. Please go to the department who is calculating taxes, and they're going to calculate it for you. Now, very important to notice over here that suppose your salary was 20,000, okay? So you come over here, this is not true. You jump over here, you check the condition. If your salary is less than 15,000, this is not true. So you come over here, salary is less than 30,000, my salary is 20,000, yes, this condition become true. And then I will actually calculate the tax, the salary minus 15,000, so 20,000 minus 15,000, that's 5,000. I take 18% of that and add it to 2,250, and that is the tax that I have to pay. And when I finish, I jump out of my if statement, okay? Now, there is only one condition when it becomes true. The first condition that it becomes true, I have to conduct the statement of that and jump out of my if statement, okay? Although the other conditions are also true, I do not conduct the statements that are in them. So suppose my salary is 20,000. When I come over here, is salary less than 50,000? Yes, 20,000 is less than 50,000. 20,000 is also less than 80,000. 20,000 is also less than 15,000, but I do not calculate my salary, my taxes based on this. I only calculate based on this, and when I finish over here, I jump out, okay? So the order what you put in the else if is very important, okay? So suppose now that you take this and you actually write it here, okay? So my program is going to come and run, and this will have a logical error in it. I am paid 20,000. I'm going to say, is my salary less than 0? No. Is my salary less than 15,000? No. So I'm going to jump to the next condition, which is this one, okay? Because these two lines are written here. I'm going to check, is my salary less than 50,000? Then that will come yes. Okay, so 20,000 is less than 50,000, and I'm going to calculate the tax based on this, and then I'm going to be paying more taxes than I'm supposed to be, and your program is going to jump out of your condition, okay? So it's going to be giving me a false indication on the taxes that I have to pay, because I actually did not put the right sequence of the if and the else, where the right sequence should have been if salary is less than 15,000, if salary is less than 30,000, if salary is less than 50,000, if salary is less than 8,000, if salary is less than 15,000. I actually put it if salary less than 15,000, if salary less than 5,000, if salary less than 3,000, okay? So the 5,000 salary is going to be always true for anyone who is coming with a salary less than 30,000. So you're going to only conduct this statement and get out, and that is going to generate an error for you, okay? So the bottom line is the order of the conditions inside the if else if is very important, because it comes with a history. Okay, when it comes to this statement, for example, in the else if, I am 100% sure that your salary is not less than 0. Okay, if you are checking this condition, I am 100% sure that your salary is not less than 15,000. If I'm checking this condition, I am 100% sure that your salary is not less than 30,000. If you shift these two together, then when you come to the condition where the 3,000, which is written over here, if your salary is 30,000, you will never reach to this condition because you have already checked that if your salary is less than 50,000, which will always be true. So the 30,000 bracket has no use. Okay, so make sure that you write the right order of the else if in your program. Now, order of condition of manipulating alternative decisions. When more than one condition is a multiple alternative decision is true, only the task following the first true condition is executed, and this is what I actually told you in the previous example. So if my salary is 20,000, the 50,000 is less than 50,000, this is true. It's less than 80,000, this is true. It's less than 15,000, this is true. But I'm only going to conduct the first statement that I encounter, and then I'm going to exit my if statement. Okay. The order of condition can also have an effect on the program efficiency. Okay, you can have an efficient program more. So you basically, what you do is the first if that you put is the if which has the highest probability of people having a salary. So most of the people have a salary between 15 and 30,000. So these are the first conditions that you put, and then you can actually optimize your code based on the efficiency. Okay. So example is, if we know that 30,000 to 49,000 are much more likely than the others, it would be more efficient if we write if salary is greater than 30,000 and salary less than 49,000, and we check this condition, then we have the other conditions, check them, because this condition, if it's true, is going to jump out, so we have less number of conditions to check in the else ifs. Okay, the nested if statement with more than one variable. In most of our example, we have used nested if statement to test the value of a single variable. However, you can have more than one variable to test. Consequently, we have been able to write each nested if statement as a multiple alternative decision. If several variables are involved in the decision, we cannot always use multiple alternative decisions. Okay, sometimes you cannot use multiple alternative decisions in multiple variables, and you have to resort to if statements only. The next example illustrates this. Well, so I'm going to just go to the next example. The example over here is the Department of Defense would like a program that defines single males between ages 18 and 26 inclusive. So you want only males that are from 18 to 26. Okay, so you might have a Department of Defense that have males and females, and they will have people who are in lots of range of ages. Now I want people to define for me the males that are ages 18 and 26. Okay, one way to do this is use a nested if statement whose conditions are test, then the next criterion only if the previous criterion are tested. Another way is to be combine all of the tests in a single logical expression. Okay, and I'm going to tell you how to do that in the next slide. So how am I going to test that? So I want the males that are married and they are between ages 18 and 26. Okay, so I start my program and I say if marital status is equal to S. Okay, so suppose a single is S. So over here I'll give you the assumptions that I have over here prior start. A single is given by the letter S. Okay, male is given by the M, and the female is F always, and the ages are given as numbers. Okay, so first of all I come and check if the marital status is S, is single or not. Okay, if this condition becomes a true, I go inside the if statement and I find another if statement, and in this if statement I say is the gender is equal to M, which is the male. Okay, so if I'm a single and I'm a male, I go inside this condition. I'm going to check if my age is greater than 18, greater or equal to 18, and the age is less than or equal to 26. This means that I got a candidate, so I print to the user, hey, I got a candidate. I have a person who is a single male, age from 18 to 26. Otherwise, if one of these conditions is not true, you're just going to jump out the if. So if the marital still was married, for example, so you're going to jump out directly from this statement. Okay, and if the statement was true, so it was single, and the gender was a female, you're going to jump out of the if statement and continue your program. And if the age was not 18 to 29 and the gender was male and he was single, you will jump out of this if statement, so you'll never print this. So this is a nested if statement inside each other, which is doing the logic that I want it to do. It's checking for me if my marital status is single and I am a gender male and the age is 18 to 26. You could write the same thing over here in an if statement, and you say marital status is equal to S, and the gender is equal to M, and the age is greater than equal to 18, and the age is less than or equal to 26. So you can combine all of these three conditions by using AND, okay, and it will generate for you the same thing. However, this code is less efficient than this code. Why? Suppose that I have very few single people in my Department of Defense, okay? Now, when I do this condition, I have to check the marital status, then I have to check the gender, then I have to check the ages, then I have to AND these, and then I have to AND these to get the result if this if is true or false, okay? Whereas over here, I'll come and I'll check, is he a marital status single? Now, if I had very few people who are single, I'm just going to jump out, okay? And I'm going to determine only the single people over here. When I give them the different number of people that I have, only the single people are going to come over here. Then I check the male. So I do not check the other conditions. I only check the single, and by that I can preempt out, and I say he's not a single, he's not a candidate. I go out. I don't have to check the other condition. Whereas here, I'm checking all conditions and then determining if the result of the if is true or false. Whereas over here, I'm checking only one condition and determining do I have to go inside and check the other conditions or not, okay? So this is a much more efficient code, and this is what we say the order where we put the statements in might make a big difference, okay? Now, the common if statement error is you forget to put the brackets, the parentheses over here, okay? So you forgot to put the parentheses over here, then that's a very common error. So you say if and you put the condition directly without the brackets. The second mistake is that you put the semicolon over here. So I'll put the mistakes over here in blue. So this is the mistake, he did not put the brackets. The second error is you put a semicolon after the if statement and then write the statement. There should not be a semicolon, you should actually hide it, and this becomes the right statement. So do not put a semicolon at the end of the if statement. Okay, so all if statement examples in this lecture have the true statement and false statement indented, okay? So usually when you actually have an if statement, please do indent. So I'm going to go to the if and else example that I had. Okay, so here's the example. So here's the if. Whatever is inside the if, I indent. Okay, whatever is inside the else, I indent. What is ever inside the else, if I indent, I actually leave a space here to tell the user who's reading that this statement is actually inside here, this statement is actually inside here. However, indentation is only for the user for visual purposes, okay? Only for visual purposes that you use the indentation. The compiler completely ignores any indentation in your program, okay? This formatting statement is very useful. It helps you a lot, and you should be practicing this in the lab and in your real-life programming where you will be doing programming, okay? Now we go to the final thing, which is the switch statement, okay? The switch statement is another alternative for an if statement. You can actually shift any if statement to a switch statement. You can shift any switch statement to an if statement, okay? The switch statement is a better way of writing a program when series of if-else is occur, okay? So if you have more than one if-else, you can actually select a switch. However, for the switch statement, you have to select one amongst all the alternatives. So the switch statement is especially useful when the selection is based on a value of a single variable, okay? So you cannot have a switch statement for multiple variables. So you have to have a single variable. This is one condition, so condition number one. Okay, the second condition is it has to be of a type int and a type char, but not a type double. That's the second condition. And why do we say the type of int and a char? Because in a switch statement, you have to write if the condition had, if you suppose if it's an integer, you say integer, if integer x it has a value of 1, do this. If the integer of x has a value of 2, do this. If the integer x has a value of 3, do this. So you basically use an integer or a character variable. You don't use a double, because in a double, if you give me any two numbers, I can give you a number in the middle. Okay? So you cannot use it with double because you cannot specify each and every possibility. In the switch statement, you have to specify each and every possibility of the input that is coming, okay? And that's what makes the switch statement a bit more difficult to use. So you only use it for integer and character, and because you can enumerate these, and you can use them only for a single value, not for multiple values, okay? So here is an example. And this example basically determines for you a class of ship. So suppose just for sake of example, that you are classifying the type of ships the Department of Defense has, okay? So you start your program with directives, and this is your main, and you say class ID, and you ask the user to enter the class ID, and you read it in a class ID and using the scanf and store it, okay? So the class ID is a ship type A, B, C, and D, for example, okay? Or B, C, D, and F. This is the example that we have. So here's how you write the switch statement. You write switch and the class ID, okay? When you write the switch and class ID, you're telling the compiler, switch onto the class ID and look at what the case is in the class ID. So it's going to look at the case that's inside the class ID. The class ID was actually entered by the user, and if the user entered a capital B, it's going to directly jump over here and start executing the commands that are here, okay? If the class ID had a C in it, a small c, you come to the switch class ID, the class ID switch is going to jump directly to the small c, and you start executing the code from here, okay? So you basically look at the class ID, and the code then jumps to the case that is written over here, and this is how you write the switch statement. Switch, and between brackets you put the variable that you want to switch on, then you put the open curly bracket and close curly bracket, and then you write the keyword case, and then you put the value over here. Since this is a character, we put capital B or small b, and then the semicolon, indicating that if you encounter B over here, start doing the statements that are over here, okay? Capital B, you start here, small b start here, capital C start here, small c start here, capital D start here, small d starts here, capital F start here, small d start here. And if you don't have, you have something called the default. This is just like the else and the if. If it's not any one of these, do this, okay? So if the user entered a capital B, do this, and it will start executing the statement from here until it hits a break, okay? So when conducting the statements, it's going to conduct the statements from here. So this is empty, so it's going to jump over here, conduct the statement that's here. This is empty. It's going to jump over here, and it's going to conduct the statement battleship. So it's going to print battleship, and then you have the keyword break. Break means the stop and get out of my switch, okay? This is what the break does. The break tells the compiler to stop and get out of the switch statement. So it's going to look for the curly bracket, close the curly bracket, and start executing your program afterwards, okay? So in a switch statement, you look at the variable, then you jump to the case directly, whatever case that you are in, and from there you start executing all the statements that are written below it until you hit a break, okay? So as soon as you hit a break, you get out, okay? So you start writing, so you start from here. So you will suppose that the user now, this is the user, example 1, the user is going to enter for you, let's say, a capital C. So if the user enters a capital C, you're going to go jump to this C case, and you're going to be working until you hit a break, and you hit a break over here and you stop. So you print cruise, and you get out of the switch statement, then you have to return 0, so you get out of your program, okay? So you actually printed cruise, and then if the user enters a B, you print a battleship. If the user enters a D, you print a destroyer. If the user printed F, it's a frigate, okay? So this is how the switch actually works. Now suppose that you actually delete this break, and I hope, okay, so this break you delete and you don't write it in your program. What's going to happen? Suppose you delete all the breaks, so there are no breaks in your program, and the user comes and enters a B. You're going to jump a small b, you're going to jump to the small b, and you're going to start conducting the statements printf battleship. So I'm going to print battleship, then this break is not there, so I'm going to go, this is empty line, this is empty line, I'm going to print cruise, then this is an empty, the break is not there, so break, empty line, I'm going to print destroyer, so you're going to be printing battleship, destroyer, battleship, cruise, destroyer, frigate, unknown ship, class, okay? And that is due to the fact that you did not put break, and the compiler will continue working on this in a sequential manner, okay, until it hits a break, or it hits the close curly bracket of your switch statement, okay? That is why it is very important to put a break after you finish a logical expression. So for capital B and small b, I want in both of these two cases, I want to print battleship and then break, okay? The break is going to take me out and do it over here. If the user enters a C or capital C or small c, I want to print cruise and then break to go out. And then if it comes capital D or small d, I want to print destroyer and then go out. If it's F, small or capitals, I want to put frigate and go out. Otherwise, I'm going to be printing I do not know this type of ship or unknown ship class, okay? So this is the example of a switch statement, okay? So you take the value of the class ID and compare it to each case in the top-down approach. So you start from the case from the top and you compare it with the case. If it stops after it finds the first case, then equals to value to the class ID. So it looks for that case ID and actually looks for the value inside the switch statement. So if I go back over here, this is a reiteration. It looks at the class ID. Whatever the value, it will stop at that and start to execute the program there. If no case is equal, it will go to the default. Okay. So if there's no case over here written which is equal to the value of this, it's going to go to the default. This is just like the else statement in your program. Okay. Default case is optional, so if you want to put it, you can put it. If you don't want to put it, you can actually remove it. Just like the if, you can put it without an else, you can put a switch without a default. Okay. The statement following, just remember, the statement following a case label may be one or more C statements, so you can put as many statements as you like. Okay. In the previous example, I have code written between the print and a break 50 statements, and it's going to conduct it until it hits a break. Okay, so that's perfectly allowable. It's not necessarily that you have only one statement. You can put as many statements as you like. Okay, so you do not need to make multiple statements into a single compound statement using braces. Okay, so you don't have to put braces and do anything. You cannot use a string such as cruise or frigate as a case label. Okay, so it has to be a type of variable, so it has to be either an integer or a character. Okay, so don't use a double. You can use a double, the compiler is not going to stop you, but it's very difficult to enumerate all the double values. Another very common error is the omission of the break, so do not omit the break. When you finish your logic, put a break so you get out of your structure, okay, the switch structure. In such execution, when you forget, execution falls through into the next alternative. It's going to go to the next alternative. It's going to go sequentially until it hits a break or the end of your switch statement, which is indicated by the curly bracket of the switch statement. Okay, forgetting the close braces of the switch statement body is also easy to do, so don't forget that, otherwise you'll have problems in your logic and your program is not going to run correctly. In the book, it says that forgetting the last closing braces will make all following statements occur in the default case, but actually the code will not be compiled in most of the compilers. So if you forget to put the close curly bracket, most often the compiler is going to generate an error for you. Nested if versus a switch, what are the advantages? It is more general than the switch. If is more general than the switch. Okay, so the switch is a particular case of an if. It can be arranged for values such as x less than 100. Okay, a switch cannot compare double. Okay, so double is very tough to compare, so you cannot compare double, so don't use a double with the switch statement. Use only int and characters. Usually if you have too many enumerations in your program, you don't use a switch. A rule of thumb is in switch, if you have more than 5 to 10, if you have more than 10, go to if statement. If it's less than 10, use a switch statement. Okay. Advantages of switch is a switch is more readable, so you can read it very easily. You can actually see if the case is this, I'm doing this. Use the switch whenever there are 10 or fewer. Okay, so the rule of thumb is 10 or fewer cases. If you have more than 10, then you are probably better off using an if statement. Okay. Common programming errors. This is a very, very common programming error. Say if x is greater or equal to 0, less than or equal to 4. This is always true. Okay, this condition is always true. It will never be false, whatever the value of x. Why? Because in the order of precedence, let's suppose that x is -5. Okay, now in math this is not true, but in C it's going to be -5. Is 0 less than or equal to -5? That is false. Okay, so this will return a 0. Okay, so let me write it. So 0 less than or equal to x less than or equal to 4. You're going to evaluate this first, and this is going to return either a true or a false. Okay, so if it returns a false, it's going to return a 0. So if x was, so x is equal to -5. So is 0 less than or equal to -5? No, so you return 0. Then you say 0 is less than or equal to 4. Is this true? This returns a false, so this returns a false for you. Okay, sorry, it returns 0 is less than 4. This is true actually. 0 is less than 4, so it's going to return true. Now suppose that my x is equal to 10, and I come over here is 0 less than or equal to x less than or equal to 4, correct? Now I evaluate my x is 10, so is x 0 is less than or equal to x? This is a true, so I'm going to denote to it by 1. Is 1 less than or equal to 4? This is true, so this will always return as true. So when you evaluate this, you always get a true, so don't write the expression this way. The right mathematical, if this was mathematical expression, if you want to write it, you have to write if 0 less than or equal to x and x is less than or equal to 4, and this is the right way of writing an equivalent statement as in math. Okay, so this is what you write if you want to write the math expression. Okay, consider the statement if x is equal to 10. This is a very, very common mistake that people do. If x equal to 10, this is an assignment statement. What happens is that whatever value of x was, it's lost, and 10 is stored inside x. Okay, this is assignment. It's just like saying x equals to 5. Okay, x equals to 5, you take the value of 5, put it in here, and if you say if x equal to 10, you take the 10 and put it into x. So x is now becomes 10. And then you say if x has a value of 10, and any non-zero value is true, so this is always true. Okay, if you want to write this, write if x equal to 10, this double equal to sign, that is checking if x is equal to the value of 10, and as this is an assignment statement. Okay, so don't fall into this mistake. A lot of people do, and this is what will test you in the exam, and be careful in the exam not to fall into this mistake. Okay, more common errors. Don't forget to parenthesize the condition, so please put the brackets from the condition, so you write the condition between brackets. Do not forget the close curly bracket and open curly brackets if they are needed in the if statement, and don't forget them in the switch statement. C matches each else with the closest unnamed if. Okay, so over here, if you had, suppose if you had the if, then an if, so then an if, and then you had else. Okay, although I have indented this incorrectly, you will think that this else is with this if. This is not true. The compiler is going to take the else and put it with the nearest if it has. So this else is for this if, not for this if. Although I indented it this way to fool you, the compiler is not going to be fooled. It's going to take all the indentation out. It doesn't matter for the compiler. So it's going to associate this else with this if, not with this if. Okay, make sure that you don't fall into this mistake. It's going to associate it to the nearest if it has. Okay, in switch statements, make sure that the controlling expression and case labels are of the same permitted type, so the variable that you're checking on and the cases are the same type. Remember that including the default statements for switch statement, and the default is actually equivalent to the else in if. Okay, don't forget the close the curly brackets in the switch statement, and don't forget the break statement and put it where it actually belongs. Okay, and this is just a reference where you can actually go and find some more examples. And with this, I come to the end of my lecture. I hope you enjoyed the lecture, and see you next time in the coming lectures.